So this talk is titled Lessons Learned Adopting Microservices, and there are a couple of components. So it's not going to be as heavy on the tech as necessarily expected. The agenda is roughly just giving some background to the situation, because this was a consulting gig I did a few years back, actually. So at that point, things were slightly different in the landscape than they are at the moment. Then we're going to go through the technical challenges to explain the approach that I took in terms of solving and migrating them to microservices architecture. And then the fun part is where some of the people challenges came in, and then also just a little bit of the learnings on the way as I went through this. And just in case the entire presentation is a flop and not interesting at all, I have got one dad joke at the end, which I think is entertaining. So hopefully people will wait for at least that. Quickly, a little bit about me. I was a developer for about 15 years before joining AWS, also a customer for 8 years before that. Built a variety of things from fintech to some medical systems, even some what's called online gaming in the in quotes. Had a lot of fun. That is actually my roof, and unfortunately that image on the left is Google Maps. You can't quite see the Space Invader of my roof. As mentioned, I am all the way down here in Cape Town in South Africa. I'm based out of Cape Town for AWS. So let's start with the technical side of things. That tends to be normally the easy things to fix, because I mean, tech fix, you've got a solution for everything. Normally that solution is put in a container and you're done. But before we do that, let's quickly start with some history. So this was a company that approached me and said, listen, we've got some challenges specifically around automation and moving to microservices, specifically moving on to AWS. We need some technical help. Can you come help us, make things better and help the teams go faster and effectively get features out quicker, because they felt that the feature velocity wasn't quite where it needed to be. Now, at that point, the company had about, I want to say, 6 or 7 teams. And their infrastructure was quite interesting. They had a couple of services running on Engine Yard. Then they had 1 or 2 services running on Heroku, and then also some services deployed manually on AWS. And it was a mix between all of these kind of working together, not necessarily integrated. Some were complete standalone systems. So it was all of the show. So basically, I sat down with the CTO, and in general, it was a fairly simple challenge. He said, well, at the moment, we are taking 2 weeks to launch a new service. We want to start using microservices because we heard it's, the thing that'll make us go faster. And you need to make that faster. So it's a very clear, measurable metric in terms of what I need to do. So off I went, and I spent time with each of the teams. I spent about 3-4 days with them just to figure out what it is that they're struggling with, what are the main headaches, and what I can do to help them speed up this 2-week launch and understand before I just come in and bulldoze through everything and change it and break it. So the first lesson there was that I wanted to standardize the builds. The reason for that is that we often had this situation where a lot of people were saying, well, it's working locally, push, and then it breaks in production. Part of the challenge was that nothing was using containers at this point in time. It was running directly with Unicorn and Nginx, being a Ruby on Rails app. Multiple Ruby on Rails app, and there was also a couple of Python applications running with Flask. So it was a little bit of chaos. So firstly, we had to sort out the whole build system. So for those not familiar in terms of the history of Docker and where it came from, this is a quick history lesson on that. And basically, first challenge was, let's put everything into Docker. And as soon as you do that, then you have the conversations around what versions are we going to use, because some of the services had been around for quite a few years. So there were a whole bunch of different Ruby versions being used, different gems being used. So I set out and said, well, okay, I've encountered something like this before. So I went and built a whole bunch of golden images. So these were tagged, for example, Ruby version dash specific minor version with potentially even pre-built gems on them, because there were some gems that are common, and then some had some more exotic gem requirements. So this would speed up the builds. People were able to pick the image that they want, and things were progressing quite nicely. And then the first interesting situation came when people started complaining that with all the containers that are running locally, their disks keep filling up, because they were based on Ubuntu at that point, and it wasn't even the light version of Ubuntu. It was just the stock standard Ubuntu container, because the focus was get the services into containers, and then we go. So off I went and said, well, let's go over to Alpine. Alpine is nice and light. It's only got what you need on it. You can work with that. And that was great for little bit of time until I started going down the rabbit hole. Sorry, I couldn't find a nice free image that I could use for rabbit hole, funnily enough. So here's a well. Basically, there were a couple of interesting challenges with moving to Alpine. The first one was that not all the Ruby versions, because some of them were quite old, could actually compile their gems given the libraries on Alpine. So I had a struggle to go back quite a few versions in Alpine to figure out and just to get Ruby building. And then once it was building, it didn't actually always work that well. The second interesting challenge I had there is that this was around the time when Alpine decided to switch from the OpenSSL library to LibreSSL library. And this required a different chain of other packages to be installed. And this actually caused, I want to say, about a week or two worth of trying to figure it out, sort out dependency changes by hand. It felt honestly like it was back in the day when I ran Gentoo as a desktop. I was young and had a lot of time and also knew all the solutions, obviously, so I ran Gentoo for 4 years as a desktop. Not the most fun, but lots of learnings. In any case, spent a whole lot of time trying to figure out how to get it and ultimately got it there, that it works, and it was running as expected. The second challenge here is that for the way they'd done this is they originally had a monolith, and they took this monolith and started splitting off things into microservices, but didn't quite remove all the code from the monolith as they split it out. So it was mostly other microservices, but still some of the functionality was in the main one. And the problem there was that they had over 1,000 tests. And when you wanted to release a new version of this monolith, it took you 45 minutes just for one build. Now imagine 6 different teams working, and when they do features, because not all the code has been shifted into other microservices, they always tend to touch this main monolith project, which meant that we had builds running in parallel, which was the second issue, because at that point they were running on a CI service that charged you on a per worker basis, and there wasn't, they didn't want to allocate more budget on increasing the worker count from what they had. I think we had at max 8 workers. Now with, at that point, about 10 or 11 microservices building, along with this main one building multiple times a day, the devs got frustrated and said, well, it's also taking way too long to actually build. So the first thing I did is, well, let me move you over to AWS Code Build, because you can spin up pretty much as many of those in parallel as you want. You can also scale vertically in terms of the build instance if you need something more beefy. And that sounded like a great idea. So the next headache was that for Ruby, you want to install additional gems to be able to test. At this point, it was like, okay, so we build a Docker image. It doesn't have the necessary gems to test. Then we build a second Docker image, add the required gems, then run tests on that. And then if that does pass, then we ship the actual original container that we built. It was a little bit clunky doing it this way around, but after a while, I actually got it into a nice pipeline. So now we've solved the basic problems. We can build a bit quicker. We can at least build a lot more in parallel than we could. So the second lesson that I tried to figure out there is, how do I enable the developers to do their own infrastructure? Because I've got a background in what's called DevOps at the moment, basically getting the developers to adopt a little bit more of the sysadmin type and operational type work, or at least think about what does their infrastructure look like when they are building a system. You don't just want to write code and tell someone else, hey, okay, cool, go deploy it. So I started off with, well, if you build it, you must maintain it, because that's one of the mottos. So off I went. At that point, I was a heavy Terraform user. So I said, cool, let me enable the developers. I'm going to give you some sample repos and sample projects that you can just clone. So off I went and said, well, we're going to be running on ECS. Here's a ECS task definition. Oh, by the way, that service does need an IAM policy and IAM role to obviously be able to run. So you just need to create these two. Don't worry about it. Then also you create the actual ECS service that references that task we just created. Also load balancer, but don't worry about the load balancer. That's in a different repo. You can just reference it this way and add your service as a target behind the load balancer. And then if you want to get to your, let's say, custom resources that your service needs, you can just go add them by hand as you would need. For example, let's say I wanted to add some kind of queuing to the service that you want to do. So, it's straightforward. I mean, I just show you the code. That's the resource you need to create your service. Not a lot of work, is it? Oh, I forgot. You also need an IAM policy and a role for the code build job. The code build job also needs an ECR repo that needs to host your Docker container. And then finally, you need some kind of deployment pipeline. So it's not that bad. I mean, it's, they're all files you can just copy and paste. sub-lesson I learned here is that with that copy and pasting, people don't always do the proper replacement. So we had a very interesting bug in production once where the service was up and running, no issues, and then it would break. And then we would say, okay, cool, well, let's just redeploy the last version that was working. We deploy it and it's working. And then we deploy the newer version and that version's working. And we're like, but what just happened here? Why is that new version working now and it wasn't working? This is the whole point behind containers. The container that you build and run locally and test is the container you deploy in production. What's going on here? It took us about 2 days to figure out that with one of those copy and pasting of all the files that I just showed you, someone had not done a replacement for the actual service name in one specific section. So they were building, let's say, service B, and when it came to pushing to ECR, they were pushing it to service A's repository. And at that point, we were still doing the whole YOLO deploy and making use of the latest tag. That we fixed at a later point, but that was a very interesting learning there first. First one is make sure that the policies that you apply to your build pipelines cannot push to any different repository than the one you are busy building. Secondly, don't use latest tags. In general, it might, especially if you're in the middle of a scaling event, you can have some very interesting side effects happen. So now we can build, now we can deploy. The next part is, well, let's handle our configs and secrets, because at that point, there were these large text files that people were copy and pasting, and everybody pretty much had a copy of every single production secret on their laptop with no protection on it. So we said, okay, let's think of a way to do this better. So off I went and had a look and a read and a fiddle, and I came up with this interesting way of doing it. So there's a service called KMS on AWS that allows you to encrypt and decrypt strings that uses keys, and you can create derived keys and multiple keys, and you don't ever get access to the actual key, but you can use it if you've got an IAM policy that allows you. So what do we do? First, we create a developer encryption key. And what we do is we create one of these per environment. So there's the developer key for the dev environment, the testing environment, the staging environment, and then also the production environment. A dev would then take that key, use a value that they want to encrypt. So let's say an API key for a third-party service or another key between services they want to use, basically anything they want to do, use that key and encrypt that string. Now, the IAM policy is interesting because the dev can only encrypt. They do not have a policy to decrypt. So once that value is encrypted, they have got mush text that, unless they obviously keep track of their bash history or share that between themselves, they shouldn't be able to get whatever it was that they encrypted again. Then how do we get this out there? Because now it's been encrypted and we want to deploy it. Luckily, Terraform has this concept of data sources. So you can define a KMS secret string as a data source. So Terraform would have access to that initial development or that dev encryption key that you had one per environment, and it's able then to decrypt the string. And then what I did is that it set it up to use a second KMS key to encrypt it again. This one, the devs didn't even have encryption or decryption rights on, and then ultimately take that encrypted string and go store it in parameter store. So now we had a nice pipeline where you can even version control your secrets because you encrypted with KMS, and unless you've got access to the decryption right, you couldn't read that string. So we committed those, and it worked for a while. And similar to the previous stuff, it wasn't that hard. I mean, you firstly defined that data source, or you had a command line string, a command line script that you could use to do the encryption for you. So you went something like AWS encrypt development, gave it a name and then the actual value, and then it would pop out a string. You copy and paste the string into a block like this. So one secret block per secret that you want to do. And then you go ahead and you actually reference it. Once again, I mean, it's readable. It's not that hard. You just copy and paste, copy and paste. It's not that hard. Then later on, I refactored it to this, but more on that later. So what did we end up with? As a dev, if you wanted to create a new service, you only had something like 20 or 30 different Terraform resources to do. And at this point, because I've been using Terraform for a few years, I wasn't quite that concerned because, yes, it's a lot of code duplication, but you copy and paste it, and it's fairly easy to understand because Terraform is JSON-like structure. You can read it. It's easy to understand, well, at least in my opinion, which brings up a thing. As soon as you understand something, you typically think it's easy, and you expect other people to think it's easy as well. Not necessarily the case. So, right, we are now at a point where we said the tech isn't in place, and we're done. Let's go for drinks. Speaking of drinks, it's a bit later here in the evening than it is there, and I was actually in London this year. Well, technically, if you can count 13 hours in the city being in London. And this is the whiskey I got on the way back. I had a scheduling conflict, unfortunately. And Ollie, I will at some point be in London again, and then we can finally go for that drink. I've not yet met him in person. So now for the second. Sorry?
I look forward to it.
Cool. So now we go on to the fun part, where, because everybody always jokes that the hard problems in tech is never tech, it's people. And that proved to be very, very, very true. So what's the first lesson that I learned there? People do not like change. And to put this in perspective, this is my daughter the other day when she wasn't allowed to walk over the pond. There's a little wall that's built with wooden bits, and it's very mossy and very slippery, and she was not happy to be allowed to walk across it. Now, bottom line here is that when you get people to change what they're doing, you have to be very careful how you approach it. Now, initially, when I did all of that Terraform, I felt that, yes, it is about 50 to 100 lines of configuration plus a new tool. But I mean, the new tool is just a binary. It's wrapped in a make file. It's in the build system. Shouldn't be that complex for you to pick up. Not taking into account that these are developers that, not all of them, but some of them had never done any kind of infrastructure as code. Second challenge was that some of them had never really clicked around an AWS console. Third challenge was that there were some that even had never done any form of infrastructure whatsoever. They had only ever in their life written code. They'd never even done, how do I deploy this, other than click the button in the IDE that makes me show what this preview looks like. So that was a very interesting challenge. I found that I need to spend quite a lot of time after putting all of this in place, showing them, and even after having all the docs with examples, with demos and everything, almost like going back to them and continuously showing them this, and this. So the lesson I also learned as part of this is that I've been doing this very frequently, multiple times a day for many years. They only interacted with infrastructure changes maybe once a month, if that. So for them, it was every single time they did it, it was learning it from scratch again. And the problem was it wasn't, for them, something that came naturally. So I need to figure out a way to do it better. Then the second problem with that was that, as with any good framework, you kind of figure out there are better ways to do it the whole time, because you're constantly jumping between service 1 and service 2 and 3, and you figure out, oh, wait, I can abstract this that way, and that makes it a little bit better. So what ended up happening there was that I constantly made changes, and basically this was what they kept on asking me, saying, do I really need to update? I don't even know why I'm updating to the new service, but I know there was a mail. You asked us to update. Do I really have to do this? Because I did lose a bit of trust with them here, because I did have initially 1 or 2 broken versions where there were some edge cases I didn't think about and things broke. So I was now in a very uncomfortable situation, because yes, I felt this was a step forward, but the teams, not all of them were happy. There were some that were like super happy and just grabbed everything, and if there was an issue, they would really dig into it. But on the other end of the spectrum, those initial devs that had never done any infrastructure, they were not so happy to do this at all. So basically, easy solution there is that I updated all 17 repos at that point every time I needed to do a change. And at that one point, this became something like a 4 or 5 hour endeavor just to get everything up to date. And then I went and scripted it, because that's what all good people do when they script it. So I initially ended up doing something like this, where I had this whole upgrade section inside the make file. So the framework for doing the infrastructure could actually upgrade itself if you ran upgrade by checking out a repository, copying some files around, deleting some things. This is literally a very brute force approach. If it broke in the middle because you did something to rename files or something, good luck. It was not a pleasant experience to try and fix it and work with it. But the developers didn't really use it because I kept doing it myself. So it helped it make better, but think about when you do this kind of shared infrastructure or shared tooling for how you change things, and specifically, for example, change the infrastructure. Make sure that it's an easy way to do it. And that leads us to the next lesson that I had, which was make the right choice the easy choice. Now, this kind of seems obvious, where you want people to do the right thing, but they're not always sure how to do it. So the best thing I found there in terms of image that matches the term, which is create a golden path. Now, what a golden path is you make it so that it's the easiest way possible for a developer or a team to do something is also the right way. And what I did there is that I found that I spent quite a lot of time doing a lot of abstraction, and we got to a point where this is what you needed to spin up a new service. So everything behind it uses convention over configuration. So you could override some portions of it if you wanted, but basically you gave a service a name. You told the specific environment how many of the service that you want, and also what the instance size was. At that point, there were some issues around being able to run multiple containers on the host with the way some of the services were interacting and also some of the performance requirements. So they ran a single container on a host, which is fine. It's not a problem. But you could say, how many containers do I want? And also the instance size to decide. Some of them needed quite beefy, compute-intensive type instances. Then also the other pain point that we had here with the people was that configuration. And while it wasn't that clunky, I felt, I managed to get it down to something like this, where it was these little blocks that they have to do on their own. And that's just for either a config or for a secret. It didn't really make a difference from the end user perspective, because that's the other interesting thing I found, is that there was a lot of confusion because you could have something stored as a config, which meant it was plain text. And also you could have something that was stored as a secret, which means that it wasn't plain text. And for me, it felt like, well, if it's an API key or if it's a database password or username, then it needs to be encrypted. Then things came out like, okay, but what about the database URL? Is that now secret or not? And it was interesting to see how people felt what landed on what side of that fence. And then what happened is that different teams had different opinions of what should be where, specifically around the database URL. And that confused the teams even more. So between the different teams, some would encrypt it and some wouldn't. And then when there was some cross-team working, people would be confused and they would actually just go and change it to be the way that they thought it was. So that led to some interesting inter-team, let's just call it disagreements, where they weren't happy about how another team was doing, and they felt like, well, don't you understand this? So another interesting challenge to do. So remember the initial challenge that I had to deal with, which was it takes 2 weeks to launch a new service, make it faster. And at this point, we'd gotten to a nice situation where we had a new hire that'd been there for about 2-3 weeks. I had taken the person through the onboarding and used the documentation and said, well, what I want you to do is take this documentation, go create a new service and do it as a tech demo, because we had weekly tech sessions. And the person did the presentation and was able to get a new service up and running in production in about 30 minutes. So obviously I thought, this is great. We are done. Woohoo. Let's have some, cake. That was a very interesting lesson. So I thought that was a great achievement, because we had now gotten the ability, that challenge that I was given initially is done. Part of it was also get us off Engine Yard and also get us off Heroku and have everything running on AWS. So I did what you do when you think things are going well. I went and baked the cake myself. It was a nice cheesecake. Made 2 of them, and I even tried to with chocolate. It didn't really turn out that well. Put the letter E and Y on each of them because we had just gotten off Engine Yard. And then had a nice discussion again with our friend, the CTO. And he said, okay, so we can close our Engine Yard account. I'm like, well, there's these 2 interesting instances that they use for batch jobs every now and again. But they're not running the whole time. They just switch them on every now and again. They are on the list to do. But I mean, effectively, the entire system that's publicly facing is running on Engine Yard. Yay, we're off Engine Yard. And he's like, but there's still stuff there. I'm like, yeah. So lesson here for me was that be very, very explicit about what the definition of success is and how you're going to go about making sure that everybody is on the same page. Because all the developers were happy because their development workflow was a lot simpler. They were all running on the same infrastructure, which was AWS, and everything else was aligned. So all the developers were happy. But this wasn't actually what was expected, other than that initial challenge, which was the speeding up of the creation of the new service. So that was a very, very interesting learning for me specifically. Then last lesson, second last lesson actually, is that some people will not change. So remember that nice golden path that I showed you? No matter how easy you make it for them to take the right route, they will choose to go barefoot over the cactuses or cacti. And they will, because they're stubborn and they simply feel that they know better. And sometimes you have to keep an eye out for specific egos, people that possibly feel their jobs are threatened because you bring in automation, because they feel that, I'm not quite sure why, because they're there to build specific services. Sorry. And they weren't happy with the fact that we automated in a specific way. They wanted to do it with a different way. For example, I implemented Chef, and they were big Ansible fans, and they were like saying like, no, we're not going to use these templates for how to use Chef to do all the things that every other team is doing. We will use Ansible, and sorry, you can't force us to use Chef. So that's the other thing, is you cannot force teams to do something that they will not do. You need to try and convince them. And if you can't convince them, let them run around like this for a while and then leave it and have that discussion saying, well, you're welcome to, but at some point you're going to have to justify why you are spending, let's say, 10 to 20% per sprint on doing things that there are better ways of doing that should not take you time. And then the biggest lesson of all of this, given the system is something that doesn't do a lot of volume, and it was complex but not that complex, is that they should probably not have split the monolith. So the initial reason for splitting the monolith was that it was getting too slow to develop because of the slow build time and the lots of tests that were running. Bigger problem actually ended up being is that it wasn't probably inside the application. They didn't split the concerns. There was no such thing as even domain-driven design ideas in terms of separating things. It was literally, this can call into that class and it's working. What's wrong with it? Which is interesting. The second other one that was interesting when we started doing the microservices route, and please take into account this is a couple of years ago, was that there was this idea of building this data bus where you can, it's almost like an enterprise service bus, except slightly different. I'm still not 100% sure what the difference was supposed to be, but this bus where you could send data between different services, because each service, as in microservices, would own a set of data, and you wouldn't have a copy of the data. Except what happened was that because all the code was still intermingled in these microservices, they ended up copying and syncing data between the different services. They literally, some of the teams built syncing services. So every time something gets changed on service A, that record would put a notification on the data bus, and every other service would go, "Ooh, I need that data," so then go and copy that record and then update local records for it, which was a very, very interesting one. And also because all the data was scattered all over this place, and what happened there is that you never really knew where the source of truth was because the data was being copied. It was very, very hard to do reports. So the last lesson there is that monoliths really are okay. It does everything, and it is hopefully not that bad for a lot of people to build. And also specifically with startups, you probably don't have time to spend getting a massive microservices architecture up and running. And if you want to get something out quickly, duct tape and Spit will get it out the door. Figure out if you can get customers rather than spending all the engineering effort to get something built that's technically very shiny, but doesn't specifically do any features. And that is almost it. But like I said, I did promise you a dad joke at the end. What did Yoda say when he saw himself in 4K for the first time? And the answer is HDMI. Thank you very much. Those are my contact details if you do want to connect with me either on Twitter or LinkedIn. And also, I currently do about 3 streams a week on the AWS Twitch channel. But you can see all the details of things that I'm busy with on either of the social media channels. So with that, thank you. I hope you found this interesting. And are there any questions? Okay, dead silence. Cool. Thanks, Raphael.
I swear this has never happened before.
Sorry, Mark.
It's always like a small period of time when nobody writes anything or asks anything, and then
Okay, so to a certain extent, it was. I've had issues in the past where you pick a specific, let's say, Ruby version, and that tag is not immutable, where it constantly gets updated, and then things were breaking. So just past experience that may be a little bit weird of doing that, where for 99% of the time you're fine, but you have that 1 or 2 times where things just go wrong. So I wanted to have local copies. One of the services did actually go that route because we simply couldn't get one of the, it was a very weird natively compiled gem to work otherwise. So we did go that route. Okay. Next question. How did you cope with a development and test environment coming from a platform engineering background? Well, that actually wasn't that difficult. The reason is that with AWS, if you set up multiple accounts, there's a nice way you can use IAM policies and roles to switch between them. So when you define your infrastructure, you just have different variable files for the different environments. So the quantities of services and those encrypted config values are the main ones. And then you say, well, deploy this in the dev environment or deploy this in the testing environment. And it just goes off, uses that and switches into that account and creates the infrastructure and pipelines for you. Similar with the deployment, when you deploy the pipeline, you use the same role switching mechanism to deploy to the different accounts. So it flips into that account, then initiates the deployment. Just to check, Daria, were there any verbal questions? Because my headphones were breaking. Okay.
No, didn't hear any.
Cool. I mean, also open to other AWS questions if anybody has any. Nope. Doesn't look that way. I think you just muted, Daria.
Yes, sir. There's one new question.
Yes. Oh, okay. You mentioned IAM roles for building pipelines. Okay. So an IAM role, IAM stands for Identity and Access Management, and it's the core security mechanism in AWS for security between different services. So you would create an IAM role with a certain set of permissions, for example, to create containers or interact with the ECS service. And then that pipeline is allowed to do that, but only that, depending on what permissions you give it. So that's what an IAM role is, and it consists of policies that you attach to it. Okay, so that's actually a fun question. The difference, how does Terraform compare with, for example, CloudFormation for infrastructure as code tools? Unfortunately, I can't comment on ARM for Zero because I've never used it. I did a webinar series last week comparing, or at least looking at all of those two along with the AWS CDK. And the short answer is that it depends on your background and your approach. So if you look at CloudFormation, it's JSON or YAML in terms of the definition language. You specify a lot of details, so you've got a lot of fine-grained control with it. And it is obviously deeply embedded inside the AWS ecosystem, being a native service. Terraform is a third-party open source project that also happens to do AWS infrastructure. It does other infrastructure as well. The syntax is JSON-like. It uses HCL, which is HashiCorp configuration language, and it approaches it slightly different in terms of it figures out the dependency graph between objects. CloudFormation does that to a certain degree as well, and the functions and the way you reference things and calculate things differs. So I would say play with both and get a feeling for what suits you best. And then the third one is an AWS CDK, which is closer to how programmers would be used to defining things by using a programming language like C#, Python, Java, JavaScript to actually define your infrastructure. So it literally looks like your code. So you go a variable, let's say VPC equals new ec2.vpc and give it a variable. So that actually is for software developers easier to use as a tool because they're used to writing code like that rather than learning a new DSL like CloudFormation or Terraform. So go play with all of them. Cool. Looking at Chris's question quickly about downside of having no central source of truth. Given the trend of, microservices communication, do you have any advice on characteristics of monoliths that should not be broken up? Well, the thing is you have to ask, if you want to break up a monolith, the big question is always, why do you want to break up? What problem are you trying to solve? Often it feels that things are getting complex because the code is a mess, and everybody says a microservice is small and simple, does one thing and one thing well, therefore this will make our lives easier. Where they don't always understand that the trade-off there is that the complexity doesn't go away. The only difference is that instead of having a very complex code base for your application with complex interactions, you now have complex infrastructure, and you're pushing the complexity that way. So the service and the code is simpler, but your infrastructure and how it interacts is a lot more complex. So usually it's one of those where if you get to a point with even good coding habits and good code design, it becomes super hard to move fast, then it's a good time to start breaking things off into microservices. Is there a free version of AWS to practice? Yes, there is a free tier. Code build also, depending on the service, has got a number of free build minutes that you get. I know with AWS Amplify, you get 1,000 minutes a month. So definitely go play around with that. There's a URL for that. I can quickly pop it in here, which is /free, where you can actually get all the details for the different services and what the free tiers are for them. What is the approach in terms of splitting the monolith in terms of data? Same database? No. So there, the answer is you do not want to share the database because that often is where the most spaghetti happens because different services just access the tables because you are there. So when you decide to move and split off, you start the new service, you get the code across that you want to use and have it point to the old database. Then you figure out what are the tables you need in that new database. And you can do fancy things like set up replication where you keep it running constantly or build your own bus system. At one point, there was one team that used Airflow with a custom built replication system to figure out deltas for rows to update their version of the data before they went and migrated the tables. Honestly, I would say build that new service until you're sure that it works with the tables that you want. Restore the old database to that new database as well. Delete the tables that is not supposed to be accessing. Go back to the old database and remove the, if you've got an ORM layer, remove the ORM models for those specific tables, keeping the data there to make sure that everything is working as you expect. Because you often learn things when the models aren't there anymore. For example, manual database migrations run using Ruby code was an interesting one when things break. So that's, try and keep it as simple as possible. Don't get too fancy with the splitting there, I'd say. So initially they kind of knew, sorry, the second question by, or another question by Antonio around how did they decide to split up the service? So there were two factors to it. Firstly, it was taking the monolith and making it smaller because it was taking too long. So there were certain segments to it. For example, one area was quite distinct in terms of the responsibility it had. So that was a very clear candidate to actually move to microservice. The second type was, hey, we've got this new functionality because we're bringing aboard these new features. And they would then immediately build that into its own service because it seemed a good way to start clean because you clean database, clean service, and just don't touch the old application. So those were the two main approaches in terms of splitting up the monolith there. Yeah. So the last question around how to split a huge monolith, doing a rewrite and basically a big bang release where you change everything at the same time. Yes, it is risky, but I do understand setting up that double writing or keeping the two databases in sync and figuring out where the source of truth is something that is very, very difficult to do and do properly. So that's not a bad approach.